privacy is obsolete. A single photo can now be used to reconstruct a full 3D environment, complete with physical properties. Autonomous agents have evolved from just text to vision action models that can play complex simulations without ever touching the source code. And maybe most importantly, open source models are now matching proprietary benchmarks in both reasoning and coding, and they can do it on consumer hardware.
The timeline has accelerated. Here is the verdict on this week's developments.
All right, first up, autonomous systems. Nvidia just released something that marks a pretty significant leap forward. We're moving past AI that just predicts things to agents that can actually do things.
It's called Nitrogen.
So what exactly is it? Well, Nitrogen is a vision action foundation model. Now what that means is that it learns to play games exactly like a human would. It just watches the screen and uses a controller. There's no cheating. It isn't reading the game's code. This is all about learning complex skills from pure observation and interaction. And that has some pretty serious implications.
And the key to its generalist ability? A massive training dataset. We're talking 40,000 hours of gameplay across a huge variety of genres. This diverse training is what allows it to be dropped into a totally new game and figure out the controls and objectives on its own. The code and the model have been released on GitHub. You can find the link for that in the description. Next up, we move from AI that can play to AI that can create. We're looking at a new tool that generates hyper-realistic video, and it finally solves one of the biggest challenges in this space, maintaining consistency over long durations. The tool is called FlashPortrait, and it comes from Alibaba's Tong Yi Lab. So its main function is to map the facial movements from a driving video onto a still image. But the two key advantages here are, one, it's about 6 times faster than previous methods, and two, and this is the important one, it can maintain the character's identity over an infinite length. This solves a major failure point we've seen in older models. And this stress test really tells the whole story. If you just look at the artifacts column, you can see how models like Fantasy Portrait and Hunyan Portrait degrade very, very quickly. The image just falls apart. But FlashPortrait, it stays highly consistent with low artifacts, even after a full minute of continuous generation. So what's the hardware cost for this? Well, to generate a 10-second video, you're going to need about 10 gigabytes of VRAM. The good news is, that's well within the reach of most modern, consumer-grade graphics cards. As you'd expect, the inference and training code are available right now. Link is in the description.
Okay, moving from animating faces to reconstructing and manipulating entire 3D worlds from a single standard 2D video.
The model that enables this is called IMC Cam.
What it does is it effectively rebuilds the environment from the original video. This allows you to then re-render the scene from a completely new vantage point, doing things like panning, zooming, or creating an orbital shot, even if the original camera was completely stationary. So how does it pull this off? Well, the core technology is a technique called homography-guided self-attention. Now, to put that simply, it uses the camera's geometry to understand the scene in 3 dimensions. This is what lets it keep all the objects and characters perfectly aligned when it reconstructs the video from that new camera path. But here's the verdict on utility versus resource cost. This one is not for consumer-grade hardware. The pipeline requires over 50 gigabytes of VRAM. And that brings us to what might be the most significant development of the week. We're seeing a fundamental shift in the AI landscape. 2 new open-source models were released that are now directly competing with, and in some cases surpassing, the top proprietary models.
The first of these is Miniax M2.1.
Just take a look at these results. On the SWE bench, which is a notoriously difficult coding benchmark, Miniax M2.1 now holds the state-of-the-art position. And as you can see, it's an open model, and it is outperforming some of the biggest closed models in the industry, including Claude, Gemini, and GPT. And this isn't a one-off. The second major open-source model making waves this week is ZAI's GLM 4.7. And what we're seeing here is a pattern. GLM 4.7 achieves state-of-the-art scores that rival the best closed models on both SWE bench and in competitive math. But notice, it also scored the highest of all models on a graduate-level humanities exam. So what's the takeaway here? The trend is undeniable. Open-source models are no longer just trying to catch up. They are competing and winning at the highest levels. And that really forces a critical question. With this level of performance, is the distinction between open and closed AI now obsolete? The timeline has clearly accelerated. From autonomous agents that can master any simulation to open source models that are outperforming proprietary systems, the gap is closing. The verdict is clear. Surveillance continues. We'll be monitoring the field and will report back. Subscribe for the next intelligence brief.